Hey guys, today we are going to sort of review something that you probably saw in Algebra 2, and we are going to be graphing rational functions. Rational functions are basically functions that have fractions in them, and it also has x in the denominator. So in order to graph a rational function, we're going to need to find horizontal and vertical asymptotes so we can kind of see what the graph's going to look like. So I'm going to start by reminding you of what the rational parent function looks like. It's f of x equals 1 over x. And so I could go ahead and plug in some points in order to make a graph of this. If I plug in x is 1, I would get that y was 1. If I plugged in x was negative 1, I'd get that y was negative 1. I could keep going. And the one big thing here is that if you plug in x is 0, you'd get 1 over 0. And that's sad. That's a bad thing. We can't do that. And so this was that graph that kind of looked really funny. I'm going to try my best to draw it accurately. And it had those branches that kind of happened. So this graph has what we call asymptotes. So we have two different types of asymptotes. We have horizontal asymptotes and vertical asymptotes. So a horizontal asymptote basically tells you about your end behavior. This is a horizontal asymptote going on the that's the x-axis. So it tells you what's going on at the end. Vertical asymptotes are it's telling you what that graph can't equal to. So we can never equal to that one point. So something that we're going to end up seeing a lot in the future is we're going to be seeing this type of notation where it's going to ask you what's going to happen as x approaches infinity. And so what we can look at is on my graph, as x goes towards infinity, as x gets bigger and bigger and bigger, this graph is going to be approaching 0. That's the end behavior. Y is getting closer and closer to 0, but not actually touching it. Okay, same deal in that negative direction. As x goes to negative infinity, we look at what my end behavior is doing, and my graph, this branch, is trying to get to 0, but it's not going to touch it, but we can say y is approaching 0 as well. Okay, now there's another weird notation that we can talk about, and you probably haven't seen this one before, and it's going to say as x approaches 0 and then put a little positive up here. All that's saying is that we're going towards 0 in the x direction from the right side, okay, from the positive side. So if I'm looking and I'm taking this x thing, so I'm getting closer and closer to 0, and I'm going to approach it from the positive direction. And I can see that my graph is getting really, really tall right here, and I would say that y would be approaching infinity. That's kind of that behavior of that asymptote. So this right here is saying, go look at 0 from the right side. Whereas this notation, as x approaches 0, negative, so from the left side, we look and we see, well, from the left side over here, it's getting really, 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 really big, but in the negative direction, so we'd say negative infinity. Those are actually called limits as you approach something, and you can go in either direction. So that's just kind of a formal definition of what that vertical asymptote is going to do. Here is how you find asymptotes on this next slide. Okay, so the biggest thing we need to remember is that if you have vertical asymptotes, you're going to set your denominator, or you're going to set your bottom of that fraction thing equal to 0. Okay, and that's going to be your vertical asymptote. Now the important thing to remember here is you can't cross a vertical asymptote ever. Never, ever, ever can you cross a vertical asymptote. Now in order to find a horizontal asymptote, there's a bunch of stuff we got to do. But there is one cool thing about horizontal asymptotes, and that is that you can cross them. Now if you remember from the other thing, horizontal asymptotes talk about our end behavior more so than they do about like what can I touch and what can't I touch. So you can cross a horizontal asymptote. Now there's a lot of different ways you can remember how to find a horizontal asymptote. I have like a little mnemonic device. So if I had this function, and this is just standing for in the exponent, that's numerator and that's denominator to kind of help me. What you're looking for here in order to find horizontal asymptotes is you need to look at the degree of the polynomial on the top, and then the degree of the polynomial on the bottom. Okay, so when I think about this, if I have a high over a low, so if my top is bigger than my bottom, high over low is going to give me no. There's no horizontal asymptote. Okay, so with this, there's no horizontal asymptote, but I've got to check for something called a slant asymptote. We're going to talk about that more in the future. But there's no horizontal asymptote if you have a bigger degree on the top. So if it's top heavy, it's heavier on the top, you would have no horizontal asymptote. Okay, now if we have equal one, so I have same over same. So like the degree of the top is 2 and the degree of the bottom is 2. That's going to be name. Okay, your horizontal asymptote is going to be y equals the leading coefficient over the leading coefficient. You actually get to name it. You find what is the number next to that one, the leading coefficient, so the highest degree, over the one, the leading coefficient, the highest degree on the bottom. Okay, and then last but not least, we have the bottom heavy ones where you have low over high. So low over high, 0 equals y, or y equals 0. Okay, so let's do a couple examples to talk about what all that means. So we have on these guys, we're finding the horizontal asymptote of this. So the first thing I've got to do is find the degree of the top over the degree of the bottom. So the degree of the top right here is 4 because that's the highest exponent. The degree of the bottom is also 4 because that's the highest exponent on the bottom. So on this one, I have the same over same degree. And so I do the name here. So I go find that leading coefficient of the first thing, that's 8. And then the leading coefficient of the bottom one is 2. So that would simplify down to y equals 4. Okay, so same means you get to name it. Now if you have something that looks like this guy, and again, I look for the degree of the top, that's 3. Then I look for the degree of the bottom, that's 4. So on this one, I have a lower one, it's bottom heavy. So I have a low over a high. So I would just say y equals 0. That's my horizontal asymptote. Okay? Again, high over low, no. Same over same, name. Low over high, 0 equals y. Okay, that's how I remember it. You might have learned Bobo and Botten last year. However, you can remember, that's great. The last thing that we need to know in order to graph something are the intercepts. Okay, so intercepts, they're just like when we graph polynomials. In order to find a y-intercept, you plug in 0 for x. Okay, and an x-intercept, you just set your numerator or your top part equal to 0 and then solve. Okay, so that's basically all you got to do here. It's a lot easier to find these when they're in factored form, obviously, especially for the x-intercepts, but it also can be useful for your y-intercepts. So let's go ahead and do some practice. Again, we're going to have to find asymptotes and intercepts when we are graphing these functions. Okay, so here's our first example. We're going to graph this thing. 2x plus 1 and x minus 1. Oh, I didn't put a graph on this page. That's so unfortunate. Okay, so the first thing that I'm going to find is I'm going to go ahead and look for those vertical asymptotes. So when I find those vertical asymptotes, I take my bottom and I set it equal to 0. So I have x minus 1 equals 0. So I have a vertical asymptote at x equals 1. Okay, then I'm going to go ahead and look for my horizontal asymptotes. Okay, and when I look here, I find the degree of the top, that's 1, and the degree of the bottom is also 1. So here I have same over same. So I get to name it. Y equals the leading coefficient of the top one is 2, and the leading coefficient of the bottom one is 1, so y equals 2. Okay, once I have those two pieces, I tend to go ahead and start graphing just to make my little guide for myself. And so I have a vertical asymptote at x equals 1, so we're just going to sketch this. I'm going to go ahead and be nice and get you a nice straight line, except for I can't go through the line that I'm trying to go through. So I have a vertical asymptote at x equals 1, and I have a horizontal asymptote at y equals 2. So let's go ahead, take off some 2's there, and then put my horizontal asymptote in. There's also an arrow at the end of mine, I don't know why. Okay, then I'm going to go ahead and look for those intercepts. So when I have my intercepts, to find my x-intercept, I take my top and I set it equal to 0. So I would have 2x plus 1 equal to 0, solve that out, and I would find out that x equals to negative 1/2. So at negative 1/2, I am going to cross that x-axis. I'm going to go ahead and put a little dot there. So that was 1/2, here's 1. I'm really not to scale today. Okay, and finally I'm going to find my y-intercept by plugging in x equals 0 into this equation. So if I plug in x equals 0 here, I would get, this guy cancels, it'd be 1 over negative 1. So my y-intercept would be at 0, negative 1. Okay, so I'm going to plot that point. So now that we have this kind of guideline, this will help you figure out where things go. Remember, we try to get really close to those asymptotes, but we can't touch them. But the thing that we did yesterday actually is going to help us out here. We're going to draw a sign chart in order to decide if things are positive or negative. The only thing that's different about this sign chart is that we're also going to include vertical asymptotes in this. Okay, so again, we're going to draw a sign chart just like we did on the notes yesterday, and we're going to put all of our zeros and all of our vertical asymptotes on it. So I have 1, 0 happening at negative 1/2, and then I have a vertical asymptote happening at positive 1. And I'm just going to go ahead and plug in values and see is that going to be above the x-axis or below the x-axis. So if I plug in something like negative 10 here, this would get me a negative on the top and a negative on the bottom, and a negative divided by negative would get me a negative. So I know that this is below the x-axis over on this direction. Okay, except for negative divided by negative is not a negative. I have no idea what I'm doing right now. Negative divided by negative is totally a positive. Okay, I didn't just change the rules of math on you. Anyway, in between negative 1/2 and 1 is 0. So I already know what that is. I plugged in x is 0 before and I got negative 1. So that is definitely negative. Okay, and then a number bigger than 1, that's like 10. So positive on the top, positive on the bottom would get me a positive number. Okay, and that just tells you, is this above or below the x-axis? So right now I could go ahead and say, okay, well this guy, it's got to cross through this point and it's above the x-axis. It's going to get really, really close to that asymptote. Now, after that point, it's going to go below the x-axis, cross my y-intercept, and try to touch this vertical asymptote. And then up here, I know that after 1, it is positive, so it's above the x-axis, and it's going to try to touch those asymptotes. Okay, and that's how I would graph that one. Find all those 4 pieces, and then draw a sign chart, and move on with my life. Okay, let's try one more example. Now before you start doing anything here, you need to make sure that you factor. Okay, factoring is #1 priority. So this is going to go and factor into x minus 3 and x plus 2. So now that's going to make my life a lot easier when I go ahead and I'm looking for all my pieces of information. So we start with my vertical asymptotes, set the bottom part equal to 0. So I'd have x minus 3 equals 0, so x would be 3. And I would also have x plus 2 equal to 0, so I'd also have a vertical asymptote at x equals negative 2. Okay, so I'm going to go ahead and let me just go make my graph already, since apparently I didn't draw graphs in here. So I have a vertical asymptote happening at positive 3 and at negative 2, so we're just going to go in there and maybe not change my pin, use that, and put some vertical asymptotes in there. Wow, I'm really bad at going through where I mean to. Okay, then we're going to go find my horizontal asymptotes. Again, look at the degree. So the degree of the top, this one's actually 0, right? Because there's nothing up there. So I have a low, because that's really small, and then I have over 2, so over high. This one's bottom heavy. Okay, there's bigger exponent on the bottom. So that means low over high, 0 equals y. So I also have a horizontal asymptote on the x-axis, and I probably should have used a line for that one too. Okay, now I go ahead and I find my intercepts. So my x-intercept, remember I set the top equal to 0 here. So if I take the top and I say 1 equals 0, that's not true, which means that there are no x-intercepts. So my graph is never going to touch that middle line, the x-axis. Okay, that's not because of the horizontal asymptote, it's just because that's how this happened to wind up. Okay, and so now I'm going to go ahead and find my y-intercept, and wherever I have an x, I'm going to go ahead and plug in 0. And again, if you plug in the factored form, it's going to take a little bit less time. So you'd have 1 over 0 minus 3 is negative 3, and 0 plus 2 is 2. So we'd have my y-intercept at 0, comma, negative 1/6. Okay, so that one's going to be kind of weird to graph. If this is 1, you know, it's like down here. Okay, so now I'm going to do my sign chart. And on this one, I don't have to put any zeros on there because remember, I didn't have any x-intercept, so I'm just going to put my two asymptotes. So I have one at negative 2 and I have one at positive 3. And I just plug in values into this. So if I pick a number smaller than negative 2, that could be like negative 10. So I'd have a positive over a negative times a negative is a positive. And hey guys, I know that this now is a positive. Okay, then I'm going to go ahead and plug in a number in between these guys, 0. I've already done that. I know that that's a negative number, so it's below the x-axis. And finally, a number bigger than 3. If I plug that in, I'd get a positive number over a positive times positive, so it's all positive on top. So when I go ahead and graph this, again, I know that this side's got to be above the x-axis and it's following the trend of those asymptotes. This middle chunk is going to be below the x-axis and it's going to cross through this point, so it's going to have kind of like a little quadratic thing going on. Well, you're going to try to touch your y-intercept, but you know, I tried. And then finally, this guy's above, so it's going to look like that. And again, it's a sketch. You can see that I struggled a little bit trying to graph that. But that should be sort of a review for you. Maybe you used Rady back in the day. You're still welcome to use Rady. It's just there's got a couple extra things that we're going to talk about tomorrow. And that's how you graph a rational function.